Hi guys, let's start a new question. I am on question number 39. Let's read the question. It says I is the in-center of this triangle. So just to clarify, this is not the center of the circle which is being drawn. This is the in-center. So if you would remember in-center is this center of the circle which is drawn inside a quadrilateral or rather a polygon. So in this case, this is the in-circle which touches all sides of the polygon once, and this is basically the meeting point of all the angle bisectors. So this is basically the meeting point of all the angle bisectors. So whichever these angles are, the bisector of these angles meets at this point I. And if I were to draw a circle with this as the center, then it would meet all the sides of the triangle once. Okay, so now that we've revised what is in center, we should not confuse it with the center of the circle which is shown in the diagram. So BI meets circumcircle of triangle ABC at D. Angle BSC is 55, angle ACB is 65. We need to find certain angles. So let's first find the big angle B. So in triangle ABC, we have 55 degree plus 65 degree plus angle ABC is equal to 180 degree, which means angle ABC is equal to 180 degree minus 120 degree, which is 60 degree. Now since this is the in center, what it means is angle ABI is equal to angle CBI is equal to angle ABC upon 2, which is equal to 30 degree. So this angle here is 30 degree. This angle is also 30 degree. Reason for this, since I is in center, which means ABI bisects angle ABC. Good, let's look at the next one. So now that we figure this angle out, I notice that ABD and ACD are in the same segment. So I'll just mark them so that it's visually clear. ABD and ACD are in the same segment, which means this angle is also 30 degree. So angle ABI is or not, let's write it, angle ABD is equal to angle ACD is equal to 30 degree. This is angle in same segment. So I think we've already done, which is we've calculated DCA, which is this part of the question done. Good, let's look at the next one. If we can still get any other angle in the same segment, angle CBD and angle CAD would be also the same for the same reason, which is angle in the same segment. So here this is CBD and CAD would be angle in the same segment. So let's just write that down. Number 6, angle DBC is equal to angle DAC is equal to 30 degree. Again, angle in same segment. So that's the second part of the question, which is also done. Let's look at DCI, which means this is the angle that I'm looking at. So angle here, this angle. Okay, so I already know this part of the angle is 30. I know this would be 65 divided by 2. Let's just write that down. Point number 7, angle ACI is equal to angle ACB upon 2, which is 65 degree upon 2, which is 32.5 degree. Reason, CI bisects angle ACB, which means angle, we need to calculate DCI, so angle DCI would be equal to angle DCA plus angle ACI. DCA we calculated as 30 and this we calculated as 32.5, which means angle DCI is equal to 62.5 degree. So this is the third part of the question which we've done. Let's look at the last part of the question, which is angle AIC, which means I need to find this angle. Now let's look at the cyclic quadrilateral ABCD. If this angle is 60 degree, then this angle obviously is 120 degree. Yes, and this angle here is 62.5. This angle also we can calculate it. This is 30. This will be half of 55, which is 27.5. Now we can look at the quadrilateral AICD. Okay, let's just write that down. In cyclic quadrilateral ABCD, angle ADC plus angle ABC is equal to 180 degree. Therefore, angle ADC would be equal to 180 degree minus 60 degree, which is equal to 120 degree. I'll need to erase some part of the question so that I have some space. So I will go ahead and erase this part. Good. So now we know angle ADC is 120 degree. Let's look at the other angle, which is angle angle CAI would be equal to 55 degree upon 2 is equal to 27.5 degree. Reason would be AI bisects angle BAC. So in quadrilateral AICD, what we have is 120 degree, which is this angle. This angle is 30 plus 32.5, which is 62.5 degree, and this angle is 30 degree plus 27.5 degree plus the angle that we need to calculate, angle AIC. All these angles would be equal to 360 degree. This is angle sum property of a quadrilateral. So angle sum property, which means 120 degree, that's 150 degree, this is 120 and 30, and this is 60, 80, 90. So this is 90 degree plus angle AIC is equal to 360 degree, which means angle AIC is equal to 360 degree minus 240 degree, which is equal to 120 degree. A very interesting question. They confused you by giving a center, but please note that this is an in-center and not the center of the circle given in the question. So you can put a star on this question. Very interesting one. Let's look at the next question that we solve. The next question that we solve is question number 41. It says calculate angle XYZ if x upon 3 is equal to y upon 4 is equal to z upon 5. So this reminds me of the chapter ratio and proportion, where we realize that in case such a question is given, we need to take it equal to a constant so that life becomes simpler. So let x by 3 is equal to y by 4 is equal to z upon 5 is equal to a constant k, which means x is equal to 3k, y is equal to 4k, and z is equal to 5k. So now we have one single constant, and this should make our life simple. Now let's look at this triangle which is given. If this is x, this angle will also be x. Why is that? That's because these are vertically opposite angles. How would it help me? Well, I don't know. Let's see what else I can figure out. If this is x, then in this cyclic quadrilateral ABCD, this will also be x. This is opposite interior angle. This angle here would be x plus y. The reason would be that this is the exterior angle of this triangle. So this would be equal to the opposite sum of opposite to interior angle. And this angle here would be x plus z, because this is the exterior angle of this triangle. Now I think I have got the answer. X plus y plus x plus z would be equal to 180. So yeah, let's just write that down. Angle BCP angle BCP would be equal to angle DCQ is equal to X, vertically opposite angles. Next, exterior angle ABC would be equal to X plus Y. Exterior angle of triangle BPC is equal to sum of opposite to interior angle. So this is X plus Y. Next is angle ADC would be equal to X plus Z. This is exterior angle of triangle CDQ. Now in cyclic quadrilateral ABCD, angle ABC plus angle ADC is equal to 180 degree. This is sum of opposite angles of a cyclic quadrilateral, which means point number 7, X plus Y plus X plus Z is equal to 180 degree. I know X is equal to 3K, Y is equal to 4K, X is equal to 3K, and Z is equal to 5K is equal to 180 degree, which means 7, 10, 15. 15K is equal to 180 degree, which means K is equal to 12 degree. 180 divided by 15, that's 12. We need to calculate X, Y, and Z, which means X is equal to 3K is equal to 36 degree, Y is equal to 4K, which is 48 degree, and Z is equal to 5K, which is equal to 60 degree. Simple one, but very interesting. Next question. The next question that we'll do would be question number 42. Let's look at the question. It says, in this triangle, in this given figure, AB is equal to AC is equal to CD. Already marked. One angle here is 38 degree. We need to find angle ABC, which is this big angle. So this angle and this angle will be equal, base angles. Next, angle BEC. They want me to find this angle. Let's see what information we have. So triangle ACD is isosceles because AC and CD is equal. Yes, I know visually the way the diagram has been drawn, it's not equal. But yeah, the question is AC and CD are equal, which means if this is 38 degree, then this is 38 degree as well. Good. Next, if I look at the exterior angle ACB, which is this angle, then I realize this will be the sum of the opposite to interior angle of this triangle, which means this would be 38 plus 38, which means this would be 76. Now in triangle ABC, this angle and this angle will be equal because this is an isosceles triangle. So this angle is also 76 degree. I still need to calculate this BEC. Let's just write whatever we know. Maybe by then we will come upon the answer to it. Let's start. So in triangle ACD, AC is equal to CD, which means therefore triangle ACD is isosceles, which means angle ADC is equal to angle DAC, ADC is equal to DAC is equal to 38 degree. Oh, they haven't asked this angle at all. Okay, so number 4 would be exterior angle ACB would be equal to angle CAD plus angle CDA, which was 76 degree. Reason, exterior angle of triangle ACD is equal to sum of opposite to interior angle. Good. So in triangle ABC, I have AB is equal to AC, which means triangle ABC is isosceles. Okay, and which means angle ABC would be equal to angle ACB equal to 76 degree. So this angle is done. So this is 76 degree. So I still need to calculate this angle. If I look at the exterior angle, then I would be able to still figure this only out, which is this. Let's see if I can get anything else. Okay, so I still can get this angle. This would be 76 plus 76, that's 140, 152, which means this would be 28 degree. How does this help me? If I can get this angle equal to something else. Yes, I think I've got it. So this is BAC and BEC would be equal to 28 degree. This is angle in same segment, which means I still need to calculate this. This would be equal to the we've already got this. We didn't want the big angle, we just wanted the small angle. I don't want this big angle. Okay, so in triangle ABC, number 7, 76 degree plus 76 degree plus angle BAC is equal to 180 degree, which means angle BAC would be equal to 180 degree minus 152 degree, which is equal to 28 degree. Next, angle BAC would be equal to angle BEC is equal to 28 degree. Reason is angle in same segment. So I had marked the wrong angle. I don't need to calculate this big angle. I just needed to calculate the small angle BEC, which is 28 degree. Good, let's look at the next one. The next question that we do is question number 44. Let's look at the question. So question number 44 says AC is the diameter, O is the center, angle AOB is equal to 80, which means this angle here is 40. Why? Because this is angle at the circumference is half the angle at the center. In this case, AOB is the angle at the center, ACB is angle at the circumference. If this is 80, then this angle is 100. Linear pair, AC is given as a diameter, which means if angle BOC is 100, angle BAC would be 50. Why? Because this is again the same angle at circumference. No, not this one. BOC, BEC. My mistake. BOC and BEC. This is not BAC. This is not at the circumference. This angle will be 50 degree. BEC and BOC. BOC is at the center, BEC at the circumference. So this is 50 degree. Next, BEC. We just calculated BEC, BCD. I still need to find this angle. Okay, since CD and AB, CD and BE are parallel, which means this angle will be equal to 50 degree. This is alternate. BCD, which is 40 plus 10 plus 50. So this is 100. And CED, we need to calculate this. This total angle is 50, 90, 100, which means this angle total is 80, sum of opposite angles of a cyclic quadrilateral, which means this is 30. Let's just write that down. Number 1, angle ACB is equal to half of angle AOB is equal to 40 degree. Reason, angle at center is equal to 2 times angle at circumference. So we got angle ACB is equal to 40 degree. Next, angle, we didn't need to calculate it initially, but let's calculate this angle. Angle BOC plus angle BOA would be equal to 180 degree linear pair, which means angle BOC would be equal to 100 degree. Next one, angle BEC would be equal to half of angle BOC is equal to 50 degree. Reason is angle at center is equal to 2 times angle at circumference. So we have got our first angle that we wanted, which is we've calculated angle BEC. Let's look at the next one, BCD. Okay, so for that I need to make this angle 50. This is point number 5. Angle DCE is equal to angle BEC is equal to 50 degree. Reason is alternate angles, which means angle BCD is equal to angle BCA plus angle ECA plus angle ECD, which is 40 degree plus 10 degree plus 50 degree, which means angle BCD is equal to 100 degree. So that's the second part of the question done. Let's look at the last part, angle CED. Now in cyclic quadrilateral BCDE, angle BCD plus angle BED should be equal to 180 degree, which means 100 degree plus 50 degree plus angle CED is equal to 180 degree, which means angle CED is equal to 30 degree. Done. That's the last part of this question. That finishes this video for me. Let's look at some homework questions before I go. Homework question for you would be question number 37. No, the 37 was the homework in the last one. So you can look at question number 41, question number 45, and question number 47. 45 and question number 47. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.